Good morning, everyone. Today we are going to start a new lesson, that is acceleration. So the learning outcomes of today's lesson, I can understand acceleration of an object. Success criteria is I will define acceleration, I will derive expression for an acceleration, and I will calculate the acceleration. So first of all, what is acceleration? So acceleration of an object is a measure of how quickly its velocity changes. Means we can say that basically to time is known as acceleration. So as I said, change in velocity with respect to time is called acceleration. So how we can change the velocity? Okay, so velocity we can change by three ways. First of all, we can increase the speed. If we increase the speed, so it means it's velocity change. If we decrease the speed, it's velocity change. And one more thing, that is if we are not changing the speed but changing the direction, so it means also there is a change in velocity. So all in three cases, the acceleration produced in an object. So now you can see a train accelerates in a straight line from rest. As it does, its velocity increases. And in the second case, now the brakes on this motorcycle are causes it to slow down. It means that its speed decreases. So when speed decreases, also there is an acceleration, but that is called negative acceleration, and negative acceleration is also known as deceleration. So it means that when speed increases, that is positive acceleration. When speed, so now how we can calculate the acceleration? As I told you, that acceleration is basically change in speed with time, or you can say that rate of change of velocity is known as acceleration. So mathematically we can write acceleration is equal to change in speed divided by time. Okay, so speed is measured in meter per second and time is measured in second. So acceleration is now measured in meter per second square. So unit of acceleration is meter per second square. Now just a small problem for that about the acceleration, that a car is racing from rest. Remember, whenever there is written a car starts from rest, it means that its initial velocity is 0. So this is rest, starts from rest, so initial velocity is 0. And this is second velocity from rest to a velocity of 27. So this is initial velocity. We will represent initial velocity by u and final velocity by v, and this is time by t. So acceleration is change in speed. Remember, change we can find out by final speed, means v minus initial speed, u divided by t. So here final speed is 27, initial speed is 0, it starts from rest, divided by time is 2. So then you can write 27 minus 0 is 27, so it becomes 27 by 2. Here, so it is 13.5 meter per second square. This is the acceleration of this racing car. So this is formula now in mathematical form. A equals to v minus u by t. Remember, where v is the final velocity and u is the initial velocity. Okay. Others, you know, a is for acceleration and t is for time. So in this case, now you can see a horse accelerates from 6 meters per second to speed of 12 meters per second in time of 4 seconds. what is the horse's acceleration? A equals to V minus U by T. So this is formula. As I told you that a race horse accelerates from 6 meters per second. So this is U, initial speed. Okay, this is final speed V, and this is time T. So V is 12, U is 6. So 12 minus 6 is 6. So divided by 4, just simplify. Acceleration is 1.5 meter per second square. I hope it should be clear now. Let's go ahead. This is now triangle formula. Just to rearrange this formula, we can calculate the speed and time by using this formula. If you want to calculate the acceleration, put your finger on the A, so you will get S by T. Same thing you can do if you want to calculate the time. So put finger on T, it becomes S by A. And if you want to find S, you can write A times T. Okay, this is the same question, so you will do practice for these questions. I will give you more. So these questions now is solved here. A car increases in speed from 10 meter to 20 meter per second. See now, let's do practice. 10 to 20. So as I told you, A equals to V minus U. So this is V, this is U. So 20 minus 10, that is 10 by 10. So answer should be 1. Let me check. Answer is 1 meter per second square is correct. Okay. Okay. Now, a bike travels at 30 meter per second, slows down to stop. This is now a little bit different thing. It's bike traveling with this speed. So initial speed is 30, U is 30, and it stopped. When it stopped, its velocity, final velocity is 0. So remember this thing here. If it is written that bike starts from rest, it means initial speed is 0. But if written bike stops, it means final speed is 0. This is the difference. Okay. So T is 15. So simple, you will write A equals to V minus U by T. So what is V? 0 minus 30 by 15. So it should be, see, minus 2. There are two, see, plus 2 and this is minus 2. So answer should be minus 2. Let's check the answers. Now you can see answer is minus 2 meter per second square. I hope it is clear now. Okay, now this is another different type of question is there. What is the question? Cyclist sets off from rest. As I told you, if it starts from rest, initial speed is 0. So U is 0. Okay, and accelerate to 0.2 meters per second. So acceleration now given, and time is 30 seconds. They are asking what is final speed. So V is unknown now. So formula is, see, A equals to V minus U by T. Just you will substitute value. A is how much? 0.2. You will substitute 0.2 equals V. V is how much you have to calculate, minus U, that is 0, divided by time, time is 30. You have to calculate V, so just cross multiply this and this. So you will write V equals to 0.2 times 30. So if you just calculate this point, you cancel, it becomes 10, 10, 3 are 30. So 3 2s are 6. Now answer should be 6 meter per second. Let me check. Yeah, answer is 6 meter per second. Let's see now, what does the gradient of a glass of the speed time graph show? Now, this is a graph now. Remember that just like distance time graph, here again, speed time graph. This is speed time graph. You can see on the vertical y-axis, this is speed. On x-axis, this is time. So speed time graph gives us acceleration. So when we find the gradient, so gradient of speed time graph, it gives us the acceleration. Okay, so for example, this graph now, its gradient, see now, this is the gradient, this is the gradient. So this will give you increasing acceleration, and this gradient shows what is coming down, decreasing acceleration. So now you can see now, this is straight slope up, it's acceleration at uniform rate. This is no slope, so it means object is not moving, so it is stationary. You can say that uniform speed, because there is a speed, so you write that it is uniform speed. If there is an distance here, so it will be in stationary. And slope down, it is coming down, so this is called deceleration. So gradient of the line in the speed time graph represents acceleration. Okay, so when you find out the gradient of speed time graph, this will give you the acceleration. And as you know the formula for the gradient, as I told you, slope equals to, I will again write for you. When you are solving the slope, formula for the slope or gradient is y2 minus y1 divided by x2 minus x1. This is the formula for the slope. So by using this formula, we can calculate the acceleration. I will give you the example. See now, this gradient is upward, so it is positive. This is downward, it is negative. Okay. So let's see here. What is acceleration of object between points A, B? See now, this is point A, this is point B. As I told you, slope is equal to acceleration, remember. So slope is how much? Formula for slope is y2 minus y1 divided by x2 minus x1. So what is y2? See now, it starts from here. Okay, this is vertical axis, this is y-axis, remember, and this is x-axis. So y-axis there is speed. So y2 second, 2 means second final. So this is y2 and this is y1. It starts from here because we are finding A to B. They are asking A to B. So this is y1, this is y2. So you can write y2 is 25 minus y1 is 5 divided by x2. So x2 is, say here this one, x6 and x1 is 2. It starts from here. So 6 minus 2. So 25 minus 5 it is 20 by 4. That is 5 meter per second square. This is acceleration between A and B. This slope by using formula of the slope. Clear? Now this is acceleration 5 meter per second square. Okay, now just same again by using slope you can find out that y2, what is y2 here now? This is y2 minus y1, so 8 minus 0 divided by x2, 4 minus 0. So 8 by 4, answer should be 2. There, check the answer. Yeah, answer is 2. Again, see, in this case now, this is y2. 4 minus 0. Okay, so you will write 4 minus 0. 4 minus 0 means 4. Divided by 8. 8 minus 0 by 8. So 4 by 8. 1 by 2. 1 by 2 means 0.5. Let's check. Yeah, 0.5 meters per second square. Okay, now in this case, it's descending downward, moving downward. So now this is y1. It starts from here and it's and here. So y2 minus y1. This is 2 now. So 0 minus 8. Okay, divided by x2 minus x1. So 2 is what? It starts and here. So 8 minus 0. Okay, that is as I do y2 minus y1. So y2 is 0, y1 is 8. Okay, x2 is 8, x1 is 0. So 8 by 8. Answer is 1, but this is minus 1 because this minus is already there. Here, let's go ahead. Now in this question, see now for all 8 seconds, speed is not changing. Speed is 4 meters per second throughout. So if there is no change in speed, it means there is no acceleration. As I told you that the formula for the acceleration is change in velocity. So there is no change in velocity. There is no acceleration. A is 0. Here. Okay. Okay, now see. What does the area under speed time graph? Now another thing, as I told you now, when you find out the slope in speed time graph, it will give you the acceleration. But if there is a graph and area under that graph you are going to calculate, you are going to find out that area will give you the speed. Okay, so sorry, distance. Area will give you the distance. If the graph is between speed and time, so if you are going to find out the area under graph, so it will give you the total distance traveled during that time. For example, now see, now this is the graph. So this is the area, this shaded area. If you find out the shaded area, you will get the total area under the graph, and this total area will give you the acceleration. Means that is equal to acceleration. Now it's up to you how you are going to calculate. Means this shape depends the shape of the graph. Now see, it looks like a trapezium. So if you know the formula of the trapezium, you can directly put the formula of trapezium, use and find out. But if you don't know, no problem, no worries. Just split this graph into 3 shapes. Now draw perpendicular from here. So it become now, see, A is the right angle triangle, C is the right angle triangle, and B is a rectangle. So use formula of right angle triangle to find the area of A, that is half times base times height. For C also half times base times height. And for B, this is rectangle, that is length times breadth. You can find that side. Show you. Now see, first of all A. For A, half time base time height. See now, what is base? This is base now. 4. And height, this one, 7. So 4 times 7 times half, it is 14. So area 1, this A is 14. Now the area 2, it's B. B is base, means this width and height. So this is now 7 minus 4, this is 3. 3 times 7, that is 21. And then again half time for the C, half times base into height. So that is half times 2, this is 2 because 9 minus 7. So base is 2, height is same 7, times 1 by 2, it is 7. Okay, now you will add all three, A plus B plus C. That is 42. So 42 meter is the total area of this graph. So it means this total 42 meter is the distance traveled by that car. So it means if you calculate the area and the speed line graph, it will give you the total distance traveled. Is it clear? So this is now your homework. I have sent you some activities also there. So in the graph paper, you will plot a graph and you can use this one also for the practice, this PowerPoint. How you will do, see, I will show you. Just for example, this is B. Put this B, hold it and bring it up. For example, here. Now C also here. It's up to you where you will take. Here. D here. Now see, this is the graph. So shade it. This is now shade. Now you will calculate the area. Same method you will use. Area under this graph, the shaded area. That will be equal to the total distance covered. There. So in this way, you will properly plot a graph. You will draw a graph. I also sent you the activities. Okay. You have to draw the graph on the graph paper, and after drawing the graph, just you will solve the question. You will calculate the total distance. You will calculate the slope. Okay. Questions are given over there. You will find out and send it to me in the Google Classroom. Okay. I hope it is clear now. If still you have any problem, we can discuss in the next class. Thank you very much. See you inshallah in the next class. Bye bye.